All right, so let's keep going with these examples. So here, using the different letters, so here I've got the second derivative of theta is this, and I give you two pieces of information, one about f and one about f prime. So you take one antiderivative, put the plus c, and then we use this piece of information here to find out what the c is. So you put the x equals 0 and the y prime equal 4. So that gives us c equal 5. You substitute that back in. So put the c equal 5 in. Now you take another antiderivative. And now I'm going to ready to solve for the c. So I use this piece of information, set it equal to 3. Make sure you're plugging in the 0, right? So cosine of 0 is 1, so that gives me a negative 1, so that gives me c equal 4. So the answer is with both of the constants plugged in with the numbers. All right, this one is different, so make sure you're thinking about this. Look at these two pieces of information. They both have to do with f. You're given f prime, so you have to go and find two antiderivatives before you can go solve for any constants. So here's one antiderivative, and then go right away to find the second antiderivative. So I've got a c and a d to solve for. So when you're given two pieces of information like this, one of them will have x equals 0. So use that one first. So put the x equals 0 in, and the y equals negative 1. I get d is 0. So that worked out nice. So put the d as 0 in. Now I'm going to use this other piece of information. I'm going to put x equal pi over 2 and set y equal to 0. So I get this here, solving for c, dividing through by pi over 2. So I get negative pi over 2. So this is my final answer. All right, so of course you remember the relationship between acceleration and position and velocity. So one antiderivative from acceleration gets me velocity. And so then I can use this piece of information to solve for c here. So I get negative 1 and 0 and c, and then this equals 2. So here we are. So c equals 3. So put that back in, then take another antiderivative. Remember, not x's, t's when you're taking the antiderivative because everything's in t's. Now use the other piece of information, s of 0 is 0. Be careful because cosine of 0 is not 0, correct? So I get c equal 3, so there's my position function. Okay, so here's another one I've given you where they're both given the two f's. So go find one antiderivative, then go find, and I simplified it before I went and found the other antiderivative using two different letters for the two constants. So then I use this one first because it's got the x equals 0. And so I use that one first, and that gives me the c equaling 4. And then I use the second one, f of 1 equals 1, and that gives me c equal negative 3. So I can plug it all in for the answer. I'll let you finish that. Then here I'm taking the antiderivative, so I get inverse tangent, negative 2x plus a constant. And so here I'm going to plug in x equal negative 1 and set y equal to 2. So you know that, put y equal to 2, you know arctangent of negative 1. So you have to think, what is the angle that if I take the tangent of it, I get negative 1? Well, that's going to be negative pi over 4. Remember that from we learned from a long time ago. Negative pi over 4. So that finishes it off for us. I'm looking like it didn't finish here, so let's do this. So take the antiderivative. So I get arcsine of x, pi x plus c. Okay, so now I'm going to plug in x equal negative 1/2. So I'd get plus pi, and then times a negative 1/2, and then plus a c. All right, so arcsine and arctangent have that restricted angle, right? It has to be between negative pi over 2 and pi over 2. So arcsine of negative 1/2 is the angle that if I take the sine of it, I get negative 1/2. So that would be this negative pi over 6. So that I get 2 is equal to 3 negative pi over 6. This gives me negative pi over 2 plus a c. So ugly things, yes? So 2. So this gives me a negative pi over 2, another negative pi over 2 plus a c. So this gives me a pi. So I get 2 plus pi is equal to c. So my final answer will be the function inverse sine of x plus pi x plus 2 plus pi. So you can expect ugly things for your c's. Sorry, that got kind of messy. Let me write it again. F of x is equal to inverse sine of x plus pi x plus the c, which is 2 plus pi.